Let us talk about density and specific gravity. Well, very useful to when we are studying engineering and other branch of sciences, including chemistry, physics, and even environmental science. No? Well, first let us discuss about density. The density of a substance is the relationship between the mass of the substance and how much space it occupies, or the volume. So basically, it is the ratio between the mass of the substance and the volume it occupies. So we can say that density is equal to mass over volume. Okay, so our M here stands for the mass and V stands for the volume. Well, density is a function of temperature. As you can see from the graph right here, we have water and NH3, ammonia. And makikita natin dito that the density of the substance is changing depending on its temperature. Well, compared sa density ng ammonia, yung density ng water is more stable, no? But for most materials, katulad ng ammonia, medyo malaki yung pagkakaiba ng ating mga density at varying temperature. Now, another thing na may encounter natin when we are studying engineering is yung tinatawag nating specific volume. Well, a specific volume is the inverse of density. It is the volume of the substance divided by its mass. Okay, so inverse lang siya ng density kapag may na-encounter kayong specific volume. So, specific volume is equal to volume over mass. Okay, so let us label that again. V is for volume and M is for mass. Now, another important thing na kailangan nating i-take note is to find out yung density ng ating substance when we are dealing with ideal gas. Okay, so how do we get the density ng ating ideal gas? So, we will be using yung ating ideal gas equation, which is PV is equal to nRT. Okay? And gagamitin din natin yung nalalaman natin about molecular weight. Molecular weight is equal to the mass of the substance over its number of moles. Okay? So, kung makikita natin, we can express the number of moles in terms of mass. Then, we can substitute that here. So, therefore, our number of moles is equal to mass over its molecular weight. Okay, so substitute natin itong N dito sa ating ideal gas equation. So, we have PV is equal to, convert natin itong N to mass over molecular weight times RT. Okay, so we're going to isolate itong mass over volume because that will be equal to our density. No? So, doing that, we will have here pressure times the molecular weight over RT is equal to mass over volume. And as we know, this is equal to the density. No? So, therefore, the density of our ideal gas is equal to pressure times the molecular weight over RT. Okay? And we will be using this equation a lot kapag nagsosolve na tayo ng mga ideal gases. Okay, so now ano naman itong tinatawag nating specific gravity? Well, specific gravity is the ratio of two densities. Okay, so this is a sort of comparison between the density of our substance of interest and our reference density. So let's say we have our specific gravity of, let's say, substance A. No? Identify na natin yung substance A. So this will be equal to the density of our substance A over the density of our reference substance. Okay, so identify natin siya dito para tandaan natin. So this will be the substance of interest. So density of the substance of interest. And this is the density of the reference substance. Okay, so as you can see, pinagkukumpara lang natin yung density ng ating substance of interest or yung pinag-uusapan nating substance and yung reference natin. So ano ba yung ginagamit nating reference substance when we are trying to get the specific gravity. So, for solid and liquid substances, the common reference substance is water at 4 degrees Celsius, okay? So, we should know the density of water at 4 degrees Celsius. And this is equal to 1.0 grams per milliliter or 1,000 kilogram per cubic meters. Or in English unit, this is equal to 62.4 pounds per cubic feet. Okay, so ito yung usually na ginagamit nating reference substance when we are dealing with solids and liquid substances. But how about if we are dealing with gaseous substances? Well, there are different references na ginagamit, but most common is yung density ng air at 20 degrees Celsius and at a pressure of 1 atmosphere, where this is equal to 1.205 kilogram per cubic meters. Okay, so ito yung usual na ginagamit nating mga references when we are getting the specific gravity ng substances. Well, as you can see, no, specific gravity is ratio ng density. Okay, so that is why it is commonly taught that specific gravity is dimensionless. But actually, if we wrote it this way, like let's say specific gravity is equal to the density, diba? Density of our material of interest or substance of interest and the density of our reference. This will be written as the kilogram mole per cubic meter of substance A, then kilogram per cubic meter of our reference. Okay, so although pareho sila ng unit, but this is actually talking about different substance and the density may vary, katulad ng pinag-usapan natin dito kanina, depending on temperature. So, in order to be precise, when you are referring to specific gravity, yung data natin should be accompanied by both yung temperature ng ating substance of interest and yung temperature ng ating reference substance. So, you can see in other references that specific gravity will be written as, okay, for example, let's say we have 1.24. Okay, so sometimes, as you can see, dimensionless na siya, no, sa ibang references. But, to be precise, you will find some references that having like this, no? Meron kang like fraction of temperature na nandito, no? So, what do we mean by that? So, let's say we are talking about liquid in here. So, ang reference natin is usually water, di ba? So, that means, itong numerator natin, katulad nung napag-usapan kanina, specific gravity is the ratio ng density ng ating substance of interest over the density ng ating reference, di ba? So, that means itong numerator natin dito na 20 degrees Celsius is when the density of our substance is at 20 degrees Celsius. And dito naman is yung density ng ating reference is at 4 degrees Celsius. So, we can say that the specific gravity of our substance is 1.24 when the substance is at 20 degrees Celsius and our reference water is measured at 4 degrees Celsius. Okay, so anyway, if you know the density of water at 4 degrees Celsius, katulad ng binigay natin kanina, well, this is equal to 1 or nearly equal to 1 if it wants to be precise. Okay, so it's nearly equal to 1. So usually yung specific gravity natin with reference as water at 4 degrees Celsius is equal na rin sa density ng substance natin. So for example here, yung density ng substance natin here will be 1.24 grams per milliliter because this is nearly equal to 1.0 grams per milliliter. So therefore the density of A will be equal to 1.24 grams per milliliter. Okay, so this is how we read yung specific gravity natin in different references to be precise sa ating data. Now, there are different specific gravity scales na may encounter natin. And I will just going to show you 4 of the most common specific gravity scales. Okay, so first we have the Boumet scale, which is introduced by Antoine Boumet in 1768. Boumet is most often used in the chemical industry, and it is expressed as light for liquids with a gravity below 1.0, no? Kapag below 1.0 yung specific gravity natin, it is regarded as light. And it is regarded as heavy for liquids with specific gravity heavier than 1.0. But in the absence of the designation kung light or heavy, it is assumed to be heavy. No? Kapag walang sinabi kung yung material ba natin in Boumet scale is light or heavy, usually ang assumption dito is that the material is heavy. Okay, so meron tayong dalawang pinag-uusapan, yung lighter and heavier, no? Light and heavy as per our definition, no? Okay, so if we have lighter than water, which is specific gravity is less than 1.0, well, ang gagamitin nating equation for the degree Boumet is equal to 140 divided by the specific gravity minus 130. Okay, so ito yung gagamitin nating reference. Alright, so medyo hindi malinaw itong ating 140. I'm just going to rewrite para malinaw yung pagkakasulat natin. Ano? So I'm going to write it again. This is 140. Okay, now, if we have heavier than water, okay, I'm sorry, but this is also wrong. This should be greater than 1.0, no? So, this is greater than 1.0. Okay, so ang gagamitin nating equation for the Boumet scale is the degree Boumet is equal to 145 minus 145 over the specific gravity. Okay, so yan yung dalawang equation na tatandaan natin when we are working with the Boumet scale for specific gravity. Okay? So, another specific gravity scale yung tinatawag nating Twaddell scale, which is introduced by William Twaddell in 1850. The Twaddell scale is a hydrometer scale for reporting the measured specific gravity of a liquid relative to water. On this scale, the specific gravity of 1.0 is reported as 0 and 2.0 reports as 200. So, nagkaroon lang tayo dito ng comparison. Sinasabi rito na kapag ang specific gravity natin is equal to 1, that is reported as 0 degree Twaddell. And if our specific gravity is 2, it is reported as 200 degree Twaddell. So the formula for this is that the degree Twaddell is equal to 200 times the specific gravity. Again, I will write here yung ating temperature as a reference. Now we have 60 degree Fahrenheit over 60 degree Fahrenheit minus 1. Okay, so ito naman yung gagamitin nating reference when we are working with the Twaddell scale. Now, another specific gravity scale na ma-encounter natin is yung tinatawag nating API scale. The API stands for the American Petroleum Institute. Now, the API expresses the gravity or density of liquid petroleum products. API gravity expresses the gravity or density of crude oil and liquid petroleum products. API is devised jointly by the American Petroleum Institute and the NIST, which is the National Institute of Standards and Technology. The measuring scale is calibrated in terms of degrees API. Okay, so degrees API, ito yung ginagamit natin for this particular specific gravity scale, is equal to 141.5 over the specific gravity minus 131.5. Okay, so again, this is commonly used in petroleum products. So if you are working in petroleum industry, well, may encounter ninyo itong specific gravity expressed in degree API. Then the last specific gravity scale na pag-uusapan natin is itong tinatawag nating Briggs scale, which is introduced or named after Adolf Briggs in 1870. Well, the brick scale is used in the sugar, fruit juice, and wine making industry. The degree bricks with symbol degree BX is the sugar content of an aqueous solution. So, ginagamit natin to in sugar, fruit juice, and wine making industry. So, ang equation naman na ginagamit natin for brick scale is that the degree BX is equal to 400 over the specific gravity minus 400. Okay, so yan yung mga tatandaan natin because you might encounter some problems na kailangan mong kunin yung specific gravity but was expressed in one of these specific gravity scales. So, kailangan pa nating mag-convert. So, kailangan alam natin kung ano-ano ba itong mga ginagamit nating specific gravity scales sa ating mga calculations. Okay? So, that's all for now, guys. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.